The original diesel engine, named after inventor Rudolf Diesel, actually ran on vegetable oil. Changes in the design of diesel engines over the years required a different fuel, with more energy output and less gelling in colder weather than vegetable oil. Hence, petroleum-based diesel gained popularity over oil. With its performance and environmental qualities, biodiesel is fast becoming a widely recognized blending agent for petroleum diesel. Biodiesel is a replacement fuel for diesel engines made out of animal fats or vegetable oil. The advantages of biodiesel are that it is not derived from fossil fuels, but can be made from local crops. It lowers greenhouse gas emissions, and the production and sale of biodiesel generates a domestic fuel economy. The University of Idaho is one of the pioneers of biodiesel research, beginning in 1979. At the University of Idaho Biodiesel Education Program Farm Scale Production Facility, we make biodiesel from a variety of feedstocks. Most of the time, we either make biodiesel from waste vegetable oil gathered from the kitchens at the university, or we extract the oil ourselves with our oil seed press. To make biodiesel, you remove the impurities from the fat or oil and change its viscosity so that it can burn in a normal diesel engine without mucking up the fuel lines. You do that through a chemical reaction called transesterification. Transesterification is the biodiesel making process and is simply a reaction of the vegetable oil and alcohol using a catalyst to speed the reaction. Let's take a moment to examine our standard recipe for making biodiesel. This is fuel production specialist Chad Dunkel, your biodiesel chef for the day. The process is relatively simple. Combine a certain amount of alcohol and catalyst mixture with your feedstock, then heat and agitate for a short period of time. The result is a layer of biodiesel and a layer of glycerin. Remove the glycerin by draining it off the bottom, then use a wash process to remove contaminants. The co-product, glycerin, has a lot of other uses like making soap, but that's another topic. To ensure that sound procedures are used and that a high-quality biodiesel is produced, we follow our quality control plan. The quality control plan provides a detailed description of our process and is available on our biodiesel education website. First, we want to make sure our feedstock is suitable for making quality biodiesel. The feedstock is filtered, pumped into the reactor, dried, and tested for free fatty acids. Excess water in the oil will result in serious processing complications, and we want fats or oils with a low free fatty acid content. Waste oil can be high in free fatty acids, while freshly pressed canola oil, for instance, is very low in FFA content and makes an ideal feedstock for biodiesel. The more FFA in the biodiesel, the more catalyst you must use, and the more soap you'll have to clean out of your finished biodiesel. For safety purposes, the batch size for our bulk production is limited to only using 2/3 of the working volume of our reactor and generally determined by the amount of methanol we want to use. For our method of making biodiesel, we add methanol at a 6-to-1 molar ratio to the oil and use a 2-reaction process batch process, meaning we perform the reaction process twice. The 2-step reaction strategy is used to ensure a complete reaction. With suitable feedstock in the reactor lid is closed, and we carefully add 80% of the methanol, which is extremely toxic and highly flammable, then 80% of the sodium methoxide, which is the catalyst we use for bulk production. The reaction mixture is then mixed vigorously for at least 1 hour at 55 to 60 degrees centigrade. After an hour, we turn off the agitation and let the product sit for at least 2 hours. The heavier glycerin settles to the bottom. We drain off as much as we can, add the remaining 20% methanol and catalyst, and agitate again. Once the second reaction is finished and the glycerin has settled, we drain off the glycerin co-product. The remaining liquid is biodiesel. However, it still has some excess methanol, catalyst, and other impurities mixed in. There are several wash methods, but we prefer to use the water wash method, which is repeated until the fuel is clean. The biodiesel is dried and an antioxidant is added. A series of tests are made on the finished product to certify it meets the ASTM biodiesel standards. No fuel will be used in vehicles unless it meets or exceeds the standards. Once the fuel has been shown to meet the standards, a biocide is added to the fuel. The finished biodiesel is a high-quality fuel ready to use in any diesel engine. Visit the website at biodieseleducation.org for more information. Thank you for watching How We Make Biodiesel.